This is the Gravitational and Electric Fields Homework Booklet question number 5. First you are asked to state Newton's law of gravitation. So you should say that the force of attraction between 2 point masses is proportional to the product of the masses and inversely proportional to the square of the distance between them. The equation on the data sheet could help you to put these words together. If you choose to write down the equation and use that in your answer, you must make sure you define all the variables very clearly. Also, to get the 2 marks allocated here, you would have to have an extra piece of detail, which would include the word attraction or the significance of point masses. Next, we're looking at an experiment carried out by Cavendish to measure the gravitational force between 2 uniform lead spheres. You're given the radius of each of the spheres. First part of the question asks you to find the mass of the larger sphere. This is just using the equation that density is mass per unit volume, so mass is density times volume. So we have the density of the lead times the volume of a sphere, 4/3 pi r cubed. We're looking at the larger sphere, so just choose carefully, and that gives you 100 millimeters as the radius. You need to convert that into meters and make sure you cube it. That leads to an answer of 47.3 kilograms. Notice the mass of the smaller sphere was provided, and you will need that in the next part of the question. So next you have to calculate the gravitational force between the 2 spheres when their surfaces are in contact. So this diagram would represent that, and you can see that the separation of their centres is now just the sum of the radii. So putting in the mass that you calculated for the larger sphere and the mass that was given for the smaller sphere and the separation of the centres that you have found into the universal law of gravitation leads you to an answer of 1.49 times 10 to the minus 7 newtons. Note that in this question the mass of the smaller sphere was given to 2 significant figures, so a 2 significant figure answer is appropriate. Finally, you're asked to consider modifications, such as increasing the size of each sphere. It is suggested that this was considered to produce a greater force between them and to improve the accuracy of Cavendish's experiment. So describe and explain the effect on the calculations in part B of doubling the radius of both spheres. So lots to notice in the wording of the question, as I've highlighted. So you need to say what happens, but you need to explain why, and you're focusing on the calculations. So you're really tracing through what you did before and considering the impact of doubling both radii. So looking back and thinking about the calculations, you found the mass of the larger sphere using the density and the volume. That means the mass is proportional to the radius cubed. So if you double the radius, this would make each of the masses 8 times greater. Ultimately, you want to know the impact on the force, and the force is proportional to the product of the masses and inversely proportional to the radius squared. So we've already considered the impact on the mass of doubling the radius, but here we also have the radius appearing in the force equation. So doubling the radius here, since it's on the bottom of the fraction, would make the force 4 times smaller. Putting it all together, we have 8 times greater for each mass and 4 times smaller because of the greater separation. Putting that all together, it leads to a final answer which will be 16 times greater. Notice this is a quantitative answer which is essential due to the wording of the question.